So in this video, we'll look at a couple of counting problems, and we'll look at a trick called complementary counting. So let's look at this question. Flip a coin 7 times. How many ways to get at least 2 heads? Let's pause and think about this question. A straightforward approach would be just look at how many ways you can flip the coins. So let's look at an example. You can do head, tail, tail, head, head, tail, tail, head. In this case, you would have 4 heads. Ooh, that's too many, one too many. So that's 7. So you have 3 heads and 4 tails. Okay, that would be at least 2 heads. And so one could try to count, okay, case by case. So for example, how many ways you could get 2 heads? And this, if you know how to do it, you know this is just 7 choose 2. That's how many ways to get 2 heads. And how many ways to get 3 heads? That's 7 choose 3 and 4 heads. And so on. 5, 6, 7. And one could solve this problem by just adding all the numbers. Okay. But we're not going to do that. And in fact, you don't need to know how to do this so-called 7 choose 2, 7 choose 3. You don't need that. So instead, we'll do a method called complementary counting. So basically, you count opposite. So what's the opposite in this case? The opposite of at least 2 heads is less than 2 heads. And in this case, it just means 1 head. Okay, now how many ways you can get 1 head? And because you're flipping 7 times, so this head could appear any of the 7 places. So there are exactly 7 ways. And of course, you need to remember that one could get 0 heads. And that means you get tail, tail, tail all the time, just 1 way, all the tails. Okay, yes, claim that that's all we need to do. Why? Because that's the complementary, and that means the remaining part will be bigger than at least 2 heads. So all we need to know is what are the total possibilities when you flip 7 times, flip a coin 7 times. Well, flip 7 times. How many different results you could get? Well, the first flip you have 2 different possibilities, head and tail. Second flip you also have 2, so this is just multiply by 2 7 times, and that's something we can calculate. And if you multiply, this will give you a number 128. And now, out of 128, there are only 7 times you get 1 head, and 1 time you get 0 head. So you get rid of these, which are 8 possibilities, you are left with 120 ways. And this, I promise you, is much simpler than adding up all these numbers. Okay, so this is the idea of complementary counting. And to use this method, the key is that the total amount, this part, should be easy to calculate. The total should be easier to calculate. And then, once you know how to calculate the total amount and how to calculate the opposite case, you will figure out the result you want by doing a subtraction. Now we look at another question. Um, so here we have a situation where basketball team has 7 players and they want to play at least one of the star players anytime. So the question is how many different lineups you can make up with this restriction. All right. So if you haven't learned Venn diagram, you know that one possibility to do this problem is drawing a Venn diagram. So a circle is where Stephen plays. Another circle is where Kevin plays. And then you need to figure out how many numbers are here. Steve and Kevin are both playing. Okay. But this is a problem you can actually also use the complementary counting. So in terms of Venn diagram, this is what happens. Is that instead of counting the inside circle, the stuff inside circle, you count outside. This part is neither playing. Okay. And the fact is, it's a very simple counting problem. If neither Steve and Kevin playing, you only have 5 players left. There are total 7 players. The 2 of them are not playing. So neither is just 1. Okay, and now you just count how many possible lineups without any restriction. So the total possibilities, the whole thing, possible lineup. How many different lineups will you have? Well, you pick 5 players out of 7. And actually the easier way is to see which 2 players you drop, because you're just picking 5 is the same as dropping 2. So you could drop 1 player, there's 7 ways, and then the next player you have 6 ways, but you double count, divide by 2, so there are total 21 ways to pick a lineup. And so the answer for the circle, inside all the circle, is 21 minus 1. 20 ways. And you can try to do the Venn diagram and figure out all the circles and you will get the same answer. But this would be an easier way. So this is another example of complementary counting. The important part is that to use this trick, you need to be able to figure out the total possible ways easily. And in this case, you can figure out the total possible ways easily. And the complementary part, the opposite part, is also easy to figure out. Okay.